Right, in this video, we're looking at exponent and log applications. There's tons and tons of real-world examples of exponential or logarithmic applications. And in this video, we'll see how to solve some of those problems. Okay, so we've already seen this formula earlier on in another video where we use the compound interest formula. I wanted to make an important distinction between compound interest or compound when you have a fixed interval and continuously compounded. If something is continuously compound, like population or some bank things, if they say continuously compounded, some are like that. But often when you're dealing with the bank, you're dealing with fixed interval interest. And so this is an example of that. And this is the formula. That's the appropriate formula to use for that. So if it's compounded something like this, semi-annually or annually or monthly or daily, if there's a fixed interval, then you want to use this formula here. So to solve this one, let's plug stuff in that we know. Find the time required to double your $2,000 investment. So that's my principal. I'm putting that in for the principal. 1 plus, they give us the interest rate is 0.05. Always remember to divide that by 100. Over the number of compounding periods, this is twice a year, semi-annually, so I put a 2 there. Bracket, n is 2, but then they want to know what the time is, so I don't know time, so time is t. But I know the amount at the end is double, so that would be $4,000. There, so I've got an equation set up where I know everything except for one variable. Now, at the start of this unit, you wouldn't have known how to solve that because t's in the exponent. We haven't had experiences with that. But now that we know all about logarithms, I can solve a question like that. So the first thing I want to do is I want to isolate this bit that's got the exponent in. So I'm going to divide both sides by 2,000. So I'll get 2 is equal to 1 plus, let me do that, that's 0.025, I think, 0.025. You can divide that to the 2 times t. Okay, now I've got that term with the exponent isolated. Next thing I would do is change its form from exponential to logarithmic form. So this would be my base, so it'll be log base. I'm just going to add that together. That'd be 1.025. Log of the base of this value here, 2, is equal to the exponent, which is 2t. Now I've got my t not in the exponent anymore. It's out, it's free, it's loose, and now I can figure out the rest of the question. So now I've got to get my decimals. Let me fire that up here. Here's my decimals. Okay, and I've got to go log. So miscellaneous, I'm going to use that log base A1 because my base A is 1.025. And then my value here is 2. And then I know I'm going to have to divide by 2, so I'll just hit divide by 2 here. Divide by 2. There we go. So t then is equal to 14.035, 14.036, I guess. If they're saying what time or how long, how many years, so you basically have just over 14 years before your money is doubled. So that's an example of using the compound interest formula. But we'll see here in another slide or two where if I have money that's compounded continuously, I'll use a different formula. And the formula you'll use is this one. So this is a formula I can use if something is continuously growing or getting smaller or decaying. And notice that the formula, I've put the other one down here just for reference, it's very similar. I guess we're using E as a base there, but notice that this here is the amount at the end of your population. P0 is the amount that you start with. And that 0 is just, it's a suffix or a subscript. It's not calculating 0. Just P0 is the initial amount. And then your growth rate constant is K. T stands for time, of course. And time can be in years. It could be in months, days, whatever the question is asking. So I'm going to use this formula in 3 or 4 different applications where I'm going to solve. Typically, I like to solve for either t or k because they're up in the exponent, but I'll use it to solve for lots of the variables. Okay, so here I've got some rabbits in Canada, and initially I had 800 million, and the growth rate is this. So they ask in the question to find the exponential growth rate function. Then they say how many rabbits are we going to have in 2009? And then after how long will the population be triple? 3 good questions. The first one's fairly easy. To find the growth rate function, all you have to do is plug in everything into this formula except for t. So P of t is equal to the initial amount of rabbits, 800 million. E, growth rate function is this. Remember to divide it by 100. If you're not sure how many zeros you need in there, make sure you divide it so you know, times t. So that's the answer to A. That's my growth rate function. Then for B, fairly straightforward. They say how many rabbits will be there in 2009. Well, you look at this year and this year, the time between them is 8 years. So I'm going to find the population after 8 years. Is equal to 800 e to the 0.014 times 8. Now be careful with doing that on your calculator. Often people just put times 8 and it becomes you're multiplying the whole thing by 8, not just the thing in the exponent. Let me show you in decimals how I would do that. Okay, I'll put decimals right there for right now. Okay, so I'd have 800, and then I need the E. Here's an E to the, and then up there I'd put a bracket, and then just go 0.014 times 8, and a bracket. There we go, 894.8. So my answer to this one, they didn't tell me to round to anything, but I'm calling it 894.8. So I'll have 894, almost 895 million rabbits if that growth rate continues in 2009. Now the next question says, I guess I can't see it, after how long will the population be triple? Okay, let's maybe keep decimals going here, and let's just keep going down. So for C, after how long will it be triple? Well, if I start with 800, there's my formula right there. So if I start with 800, if it triples, that'll be 2,400 rabbits times E to the 0.014, and then I put a T there because I don't know the time. So in this case, I'm trying to solve for time. These are my favorite ones where you have to solve for the exponent. Okay, to solve this, I need to isolate this term, so I'll divide both sides by 800. So 2,400 by 800 will be 3, is equal to E to the 0.014 t. Change it from exponential to log form. So it'd be log base E of 3 is equal to 0.014 t. Log base E of 3, or log base E is just ln, so it'll be ln of 3 divided by 0.014. That'll give me what my time is. Let's bring back decimals, see what that figures out to be. So ln of 3. Functions, I want ln. Miscellaneous ln. And then of 3, bracket, divide 0.014. There we go. 78.5. So t will be equal to 78.5 years. So that's how many years it'll take before I've got 2,400 million rabbits. That's a lot of rabbits. That's wrong. Okay, oh, here's a money question. Let's see what formula I have to use. I'm going to use either this one. As soon as I see money, I'm thinking this formula, or I'm thinking this one, this new one that we're using, e to the kt. And it all depends on how it's compounded. If it's compounded continuously, then this is my formula. If it were compounded yearly, then it would be this one. But that is not the formula for this question. Okay, so I've got $1,000. It grows to 1,500 in 2 years. What is the interest rate? Oh, well, let's write our formula and see what kind of stuff I can plug in. P0e to the kt. So I have $1,000. That's initial. It grows to 1,500, so that'll be final. E to the k. They didn't tell me the interest rate. Oh, that's what I'm looking for. So k, and it did this in 2 years, so this would be a 2. Okay, so this is a question exactly like the one that we just did. And hopefully you'll get, so you just sort of go, whoops, that was odd. So it'll just be automatic what you have to do. So this one I'm going to divide by 1,000. So it'll be 1.5 is equal to e to the k times 2. And then log base e of 1.5 is equal to k times 2. As I keep going, it'll be ln of 1.5 divided by 2. That's equal to k. All right. I'm finding it faster just to grab decimals here and do it than use my calculator. So ln function miscellaneous ln of 1.5 bracket divided by 2. Right there. 0 point, so k is equal to 0.2027. So that's like 20%. Well, as if you're going to get that kind of interest rate on your money. Okay, then they say, what is find the exponential growth function? Okay, I'll just leave decimals up there for a second. So the exponential growth function, that's where I plug in everything except for t. So p of t is equal to start, 1,000, e to the k I just figured out was 0.2027 times t. So that would be the growth function. You plug in everything except for t. Then it says, what will be the balance in 20 years? So for C, I'm going to do, well, the balance of the money after 20 is going to be 1,000 you start with, e to the 0.2027 times 20. So now I'll just plug that into my calculator. Maybe. Okay, you just plug that into your calculator. I'll let you do it. Okay, now let's do the last question. After how long will the initial stuff be doubled? So for D, they want to know when it's doubled. So here's my formula. P of t equals P0e to the kt. So if they want to know after how long it'll be doubled, if it starts with 1,000, then doubled would be 2,000. E to the k is 0.2027 times t. So you divide both sides by 1,000. 2 is equal to e to the 0.2027 t. And now you'll solve for t. Change it to log form. Well, I'll do it. log base E of 2 is equal to 0.2027t. Divide both sides by 0.2027, 0.2027, and you get t is equal to something. Put that on your calculator. Okay, next question. I think there's the last one. And this is similar to one we just did. These ones where they ask for what percent loss, 25%, you have to be careful with that. Reason that out logically. Okay, it says carbon has a half-life of 5750 years. And just so you know what that means is if something starts at 10 grams, then it decays down to half of that. That's what half-life means. And it does that in 5750. It would take 5,750 years to go from 10 grams decayed down to 5 grams. That's what that means. Okay, then they say the percentage carbon-14 left can be used to determine the age of the material. Yeah. If a sample of the scroll has lost 25%, how old was the scroll? Okay, this was a difficult one because this is actually two questions combined into one. And what you have to do, what I do, is I write the formula down. So P of T equals P0 E to the KT. And then I see what kind of stuff I know. So if they say something has a half-life, that tells me what the initial and the final are. And it doesn't matter what you start with. So you can say, well, I'm going to start with 10 grams. Then in the end, if it's a half-life, I would end up with 5 grams. Okay, and they say it takes the time for that is 5750 years. So I've got E to the K, I don't know, but I know that the time is 5750. Notice I didn't use that 25% at all. And I will have to later, but at this point here, I've got an equation where I only have one variable and I can solve for it. And that's an important thing for you to do. And you'll find in many of the questions, the first thing you have to do is find what the interest rate is or the growth rate or the decay rate, find that, and then use that K in the second part of the question. Okay, let's solve this one just like we've solved all the others. Divide both sides by 10. So you get 0.5 is equal to E to the K times 5750. Change it from exponential to log form. So be log base E of 0.5 is equal to K times 5750. Now let's divide both sides by 5750. So this would be ln of 0.5 divided by 5750 is equal to K. Okay, let's figure out what that is. Bring back decimals and see. Hopefully it doesn't blow up this time. Okay, I'll put it right there. Okay, so ln functions ln of 0.5 bracket divide 5750. There we go. Ooh, that's a small number. Negative 0. How many zeros are there? 3, 2, 3, 1, 2, 0, 5. Let's try that for our K value. Sometimes it's nice to keep more decimal places, but that's 4 sig figs right there. I think we'll be okay with that. Okay, so that's my K value. And so if I wanted to, I could rewrite the equation. Let me move this out of the way. So really the equation is, and the general function would be P of T is equal to P0 E to the K, and the K is negative 0.0001205 K. So now they ask the next question. They say, if a sample of the scroll has lost 75%, how old was the scroll? So it lost 75%. So if you're talking percent, it must have started at 100%. So if it loses 25%, then I'll be down to 75%. Okay, now I can figure out how old that scroll is or how old it is. because I've got e to the negative 0.000125 times k. And I've got a formula, and I've already done this 4 or 5 times. Divide both sides by 100. So I'll get 0.75 is equal to e to the negative 0.000125. Careful when you're writing those down that you don't lose zeros. Change to log form. So log base e of 0.75 is equal to negative 0.000125 times k. Divide both sides by that, you get k is equal to ln 0.75 divide negative 0.000125. Let's see if my decimals can figure that out for us. So ln functions, ln 0.75 bracket divide negative 0.00, well, 0, 1, 2, 2, 0, 5. Well, too many fives. Backspace, is that right? Yeah. Okay, so then, oh, I put a K there. I should have been a T. Hopefully you picked up on that. This should have been a T here all the time. T, T, T. So the time is, so the age of those scrolls would be 2,387 years old. Okay, so we have looked at a number of different log and exponent applications and saw that there was a similar way of solving each one of those. Be careful with the questions with the percent. Sometimes they say you lose 25 or you have 25% left. Just be careful with that and logically determine what those are. If you have any questions, as always, give me a call.